Okay, if you look up on the board, simplifying square roots part 2, radicals. They're called radicals as well. Radical expressions are what we're going to deal with. Radicals are never simplified if, or square roots are never simplified. Any expression with the square root is never simplified if each square root, of course, is not simplified in simplest radical form. Okay? There cannot be a square root in the denominator either. We are going to learn how to get rid of the square root in the denominator. Okay? We'll get to that in just a second. If you ever, if your square roots, if an expression you have, the square root's not simplified, the expression is not simplified. From this point on, you have to understand that. If you have a fraction with a radical in it, each square root has to be simplified, and there cannot be a square root or radical in the denominator or on the bottom. Okay? It cannot be there. There is a way to make it where it's not there. Okay? Also, over here to the left on properties to know, we kind of already gone over the first one, that square root of x times square root of y is the same thing as saying all under one square root of x times y. Haven't we already established that with the way we've simplified square roots? Agreed? You can split them into two, or you can combine them if they're both under the what? Square root. However, the same thing works for division. Square root of x divided by square root of y is the same thing as saying square root of x over y. So that wouldn't have helped you in simplifying the radical I have as the example over here to the right on number 2, because that is, even if I made it all under one square root, that's the square root of 5 over 7, correct? That's a simplified fraction, but sometimes you might find that if you combine it into one and simplify it, your radical may go away after you then split it back apart. Number 3 is a kind of just a representative form of saying that, why do you think I could add the 2 and the 3 there on number 3? Does anybody have an idea? We can sit up and do jumping jacks if we have to get loose, awake. Huh? Because they're like terms. Why do you think they are like terms? What kind of jumps out at you? What did I do? And I can add another one up there to kind of push you in the right direction. Make this 5, or I can scoot this down. Still put my stars back up there. And remember, this is something that, you almost have a lot of sections to work on now, but it is a review, so we are kind of going over it fast. What do you think I'm trying to say now? What is the difference between 3 and 4? Anybody tell me? Well, in 3, I was able to combine the 2, correct? Does everyone agree? In 4, was I able to combine the 2? Why do you think that is? What's the only difference between this expression and this expression? There's a y underneath the what? This radical here, and there's an x here. Why do you think I could add those two? She said because they're like terms, but why are they like terms? They have the what? Exact same thing under the what? Radical sign. When adding radicals, in essence, for instance, 3x plus 2x, that's equal to 5x, right? Saying 3 square roots of 3 plus 2 square roots of 3, these are like terms the exact same way these are. They have exactly the same. You can think of these like an x. It's a like term as long as the square root is what? Exactly the same number underneath it. So, just as this is 5x, what would this be? We have 5 x's here, right? You had 3 x's sitting over here, you had 2 x's over here. When I combined them, I had a total of what? 5 5 x's, correct? So I have 3 square roots of 3 sitting over here and 2 square roots of 3 sitting over here. How many square roots of 3 do I have? I have a combination. I have what? They are like terms, just like a variable. Okay? Now, at the same time, guess what? Do you think I can combine these two right here? Do you think those two are like terms? No, because one has square roots of 3's, the other one is a what? Square root of 5. Radicals, when you're combining them, when you're adding and subtracting them, you need to think of them, the radical, just like a variable. Remember how these weren't like terms? So, I mean, this simplified, so you basically can't do anything to it. You remember combining like terms when you had 3x squared plus 2x? Were they like terms? No, because they're not exactly the same terms, are they? So simplified, you can't simplify that anymore. These have the exact same properties. Unless these radicals are exactly the same number underneath them, you cannot combine them. So like I said again, it should be something you've heard of before. Now, back to the 5th property, probably the one you use the most today, is that the square root of x times square root of x will always give you x as an answer. What am I saying there in layman's terms? If you were to describe it in words, x is meaning any number, right? So if I write x again, I'm meaning the same number. So I'm saying the square root of the same number times the square root of the what? Same number will always give me as an answer that same number without the what? Without the what? Square root sign. Why do you think that is? Well, what's square root of 3 times square root of 3? When you combine them and multiply them, you get square root of 9. What's the square root of 9? What's square root of 5 times square root of 5? It's going to be square root of what? What's the square root of 25? So multiplying it times itself, a radical times the same radical always gets rid of what? A radical. That's how you get rid of a radical. Square root of 121 times square root of 121. Do you think, do we want to multiply that out, or what do you think the answer is? Can anybody tell me? No. Oh, right. But you're right. Square root of 121 times square root of 121. I don't need to take the square root because it's the square root of the same thing times square root of the same thing. The answer is what? Which is 11 times 1. 11. The square root of stick-faced man times square root of stick-faced man equals, can you guys guess what the answer is here? Stick-faced man without a what? Without a radical. Do you get the point I'm getting at? You guys are so half asleep I can't tell. Do you guys understand what I'm saying there? So anytime you want to get rid of the radical, multiply times itself, right? And the radical will always go away. Remember that. We're going to use that right here to get rid of the square root on the bottom. Okay? Any questions on any of those concepts? Can't get you to talk any English. I thought you could ask a question, but you could try. But do you guys understand this? We're good everywhere here. We've got that. We ought to be able to do the things we're going to do today. What we're going to do today is first we're going to deal with expressions where we're adding two radicals. So let's start with our first example down here. And in essence, your directions on every single problem are simply going to be simplify. Of course, I had show all steps and working blocks in your answers. Okay? first step, and write this down, needs to always be to first step. That was pretty bad English. Sure, each radical is simplified. So I'm talking about each term separately. Should have done just about 100 problems if you finished your worksheet of simplifying radicals. If you don't know how to do that, you're going to struggle on this. You need to get that shored up. At some point today when we're done, you might do a couple of these problems, but then you might use the I have a key for the worksheets you did. You need to make sure you're doing them correctly. Okay? Very important. First step, make sure each radical is simplified. So look here, is that one simplified? What's the largest perfect square factor of 3? 1, simplified. Radical 2, radical 5, is that simplified? Large perfect square factor is 1. How about 3 radical 3, is that simplified? How about 4 radical 5? Okay, they're all simplified. So the only thing left to do is see if there's some simplifying to do. The only thing left to see now, so each one is simplified. Now, combine any like terms. Do I have any like terms? How am I going to define like terms? Things that have the same what? Number under the radical. Do I have any radical 3 terms? I have another one right here. So when I combine those, what do those combine to? Huh? Remember, when there's nothing in front of us, what's understood to be in front of us? Just like x, there's understood to be a what? So I have 1 radical 3 and 3 radical 3's. That makes a total of what? Next one, combine. Do I have any other type of terms? What type of term is this? What type of term? I call this one a radical 3 term. What do you think I'm going to call that one? Any more radical 5 terms? Right here. Well, what's different now? What did I throw in there? But this shouldn't be a problem. It's no different than saying 2x minus 4x, isn't it? What do you get? A negative 2 radical 5. Are these like terms? Is there anything else you can do to this? No. So other than simplifying the radical, in essence, is this any different than a really easy Algebra 1 concept where I give you a bunch of things and say combine like terms? All I'm adding to it is simplifying the radical. Okay. You know, and that's the thing, the reason I say always make sure your radicals are simplified is for this reason. Right now, do I have any like terms? Obviously no. But the pretty big numbers, don't you simplify it, if in simplified form, they might be what? Like terms. There's a chance. You don't know that. They don't look anything alike right now, do they? Let's simplify it. And I'm okay if you make this a little smaller underneath here, but I still want to see it. How would I split this one up? What's the largest perfect square? It's factor 24. What's the largest number on this list that will divide into it? 4. So this would become square root of 4 times square root of what? 6. Okay, making this one what? Simplifying to what? Somebody tell me. All right, 2 radical 6, okay. Now, don't forget your negative right there, right? Now, how about 96? What's the largest perfect square up here that'll go into it? See, this is where you can save a lot of time by making sure you get the largest one so you don't have to break it down a bunch of times. Largest number up here that'll divide into 96 even. 16? So it'd be square root of 16 times square root of what? See, if you've done those 100 we did, you probably have done that one before, haven't you? What is the square root of 16? So what does this become? 4 radical 6 minus 4 radical 6. Now, what about 150? What's the largest number up here that will divide into it evenly? The largest perfect square number up here that will divide into 150 evenly? Huh? 25. Okay, so I can make it, so I'll go ahead and write my sign, because my sign won't change. So plus, let's see, square root of what? 25 times square root of what? What times 25 is 150? Huh? 6. What is the square root of 25? Huh? Okay, we went from having 3 terms that looked absolutely nothing alike to after I simplified, do I have some like terms here? Absolutely. So you see kind of why simplifying the write-up can be handy when you're dealing with some math here. It makes it easier to deal with. Brings every number closer together. It's being in the same terms. Now, when I combine all of these, are all of these like terms? They're all radical 6 terms, aren't they? So I have 2 minus 4 is what? Negative 2. Plus 5 would be what? So all of that simplified to that right there. Make sure we have that written down. So, is that concept very hard? Is it much different than what we did before? All we're doing, all this is saying, having 3 problems from yesterday's assignment, and then seeing if they're, after you simplify them, see if they're like terms, right? So, some more of the same. Great? Once everybody's got that written down, we're going to talk about how to get rid of the radical in the denominator. Has everybody got it written down? Our race? Make sure the video is showing everything it needs to. Yeah, it is. Okay. So now, we're going to talk about getting rid radicals in the denominator. I probably didn't spell that right, but you simply do it like all you do is multiply by 1 in concealed form. Probably tells you nothing. I'll show you what it means here in just a second. you do it is I'm going to basically give you a formula on how to do it every time. You start with this right here, correct? Anybody tell me what happens when you multiply something by 1? Does it change? Huh? The value of it does not change, does it? Because obviously when we're getting rid of something, or getting rid of the radical and denominator, we don't want it, we're not trying to change it into a different number. We want it to stay the same value, correct? So what we do is we multiply 1, but we multiply by 1 in concealed form. Well, how did, over here under properties to know, which property looks like it would help me get rid of a radical? What number? 2. It could. You're right. This one could help you if you could reduce it. But if you combine them right here, you can't reduce x over y, can you? Because you don't know what number x or y is. This can help you sometimes if you see the fraction, because you might reduce the fraction and then one of them may be a perfect square, and then your radical's gone, right? But 1 and, or 2 and, but most importantly, the one I've got a bunch of stars around, which is 5. Because the square root, any square root times itself, the answer is always what's under the square root without the square root, correct? Basically, this is the definition of getting rid of that what? Doing this gets rid of the what sign. Keeps everything the same, gets rid of the radical sign. It doesn't actually keep everything the same, makes it much bigger. So, if I don't want the square root of y to be there, what could I multiply if I did not be there anymore? If I multiply it by square root of y, over here, I would just have what in the denominator? I would just have a y, would I not? Does everyone agree with that? So that would get what I want done. But, have I changed the number? I mean, think about it. If you have 2 over 4, and I multiply the bottom by 4 only, has it become a smaller number? Is 2 over 4 the same thing as 2 over 16? It's not, is it? It's a much smaller number. Okay? So we've changed what it is. How can I keep this fraction the same over here? If I multiply the bottom by 4, I multiply the top by 4, this now becomes 8 over what? What is 8 over 16 reduced to? Right? Which then reduces to 1/2. All of these are equivalent, aren't they? So if you remember, when you're reducing fractions, if you divide the bottom by a number, you have to divide the what? Top by the same number, or vice versa. So for us to keep this equivalent over here, if I multiply the bottom by square root, think of it like an equation. You guys should remember having to, with fractions, if you do something to the bottom, keep it the same, you have to do what? Exact same thing to the. So if multiplying the bottom of the fraction by square root of y helped me get rid of that y in the bottom, what do I need to do on the top? Multiply it by square root of what? Now, do you see how I've multiplied times 1 in concealed form? Isn't the same thing over the same thing always 1? So I've kept it the same because I'm multiplying it by 1. It's just a 1 in disguise. Isn't 4 divided by 4 always 1? Isn't 10 divided by 10 always 1? Isn't stickman divided by, I like stickman, always 1? Same thing divided by the same thing is always what? So I've kept this the same, but what happened as a result? That when I combine these, now I'm going up to this right here, this becomes square root of what? I have 2 equivalent statements, but what's the difference between, what's the difference between here and here? Here there's a radical in the what? Here there is what? That's how you do it. So when you have a problem like this, into some practice. How about square root of 2 over square root of 3? First of all, if I try to reduce that fraction, does it help me any? Can I reduce 2 over 3? Can I? Is each square root reduced? And you can actually get the right answer either way. You don't have to reduce each square root first if you don't want to. But it helps to look and see. There's no other avenue for me to get rid of this radical on the bottom than to do what? Multiply it by 1 in the zero form. So what am I going to do? How do I make radical 3 not have a radical anymore? I multiply it times its what? So I'm going to multiply square root of 3 times what? Leaves me what? 3 right there, right? Everyone agree? But what allows me to do that? If I multiply the bottom by square root of 3, I have to multiply the what? Now, you always need to reevaluate whether your radicals are simplified after you're done doing this. Because you could have, there's a chance you start with something that each radical was simplified, but after you multiply it times another radical, that number on the top may need to be simplified. That square root. But now you've kept everything the same, you've simplified it, you've gotten rid of the radical on the bottom. There's 2 ways you can do this. First, I always suggest looking and seeing if the fraction can be reduced. If you combine them and use number 2. Look and make sure number 2 won't help you. Does number 2 help you? If I combine this to the square root of 14 over 7, what happens? It becomes the square root of 2 over 1, right? What's the square root of 1? 1. So this just becomes the square root of 1. Now you could get it right. You get it right by multiplying by square root of 7 over square root of 7, but you're going to have a radical to simplify. And if you simplify that radical, it's going to eventually, it should reduce to square root of 2. So make sure the easy path is a possibility first. Just the same as when you're simplifying a radical, make sure that number underneath there is not a what? Perfect square, right? If it is, you don't have to go through all these steps. Any questions there? So I'm going to add another step here to our properties. Okay. All right. Of course, there'll be more complicated ones than that. I'm going to do 1 or 2 of them, but then I'm going to let you get started. Now, can the fraction 10 over 9 reduce any? And I'm not interested with mixed numbers. Those just about become useless except for coordinate planes and measuring things from this point on in your math. It may not quite be useless, but it's much more handy to keep things as an improper fraction. All right, so there's nothing I can reduce, is there? So my only thing left for this to be simplified is to not have what in the denominator? Radical. So I need to get rid of it. How do I do that? By multiplying the bottom by square root of 9 and multiplying the top by what? If I do that, I'm okay, right? What do I get as the result? Square root of what? Over what? Everybody see that? Now, actually, what am I saying? This was a dumb problem. Why was it a dumb problem? Anybody tell me what the square root of 9 is? There's your answer. Sorry. I was thinking of one on the top of my head. I'll get your worksheet. Everybody see that I didn't do it the easy way there? A lot of these can be made so much easier if you'll just reduce them. Now let's go ahead and do this one, and we won't reduce it. We'll do it both ways. Okay, this one right here. Let's say I decided not to reduce the fraction before I start trying to get rid of it. Because some of you are better at seeing the fractions can be reduced than others. If I just simply wanted to go with the idea of getting rid of this in the bottom, what would I multiply the bottom by? What would I multiply the top by? Square root of 30, correct? I'll leave this up here. It's the last thing we're doing, so you don't need to write, just watch. What is square root of 30 times square root of 30? Anyone? Right? Well, what's square root of 6 times square root of 30? Square root of 180. Now, obviously there's going to be some simplifying to do there, isn't there? You guys see that over here? You guys see? What's the largest number up here that'll divide into 180 evenly? It's actually 36. You guys see that? 5 times 30 is 150. 5 times 6 is 30. What is the square root of 36? So this is now 6 square roots of 5 over 30. Do you think you're done? Anybody tell me why? Right. Remember, you can multiply things that are both outside the radical, or you can divide things that are both outside the radical. So 6 goes into 6 one time, 6 goes into this what? So your answer is actually what? Radical 5 over 5. Now, what would have been the easier way probably to do this? That would have been to simplify, to use property 2 up there and say square root of 6 over square root of 30 is the same thing as saying what? Right? And reduce that from the start, correct? Now, here's what I want you to be careful at. You got a lot of people make mistakes. 6 goes into 6 what? 6 goes into this what? So this becomes the square root of 1 over square root of 5, correct? You can't just get rid of the square root somewhere unless it's perfect square. What is the square root of 1? So it's 1 over square root of 5. Are you done? You're in great shape except for what? There's a radical on the bottom. Do I get the same answer? So you've got 2 ways to do a problem like this. I'm going to get you started. We're going to do some that have coefficients as well. In other words, 2 square roots of 6 over square root of 30, things like that.